My name is Angela. I am the STEM counselor. I think I've met with most of you. If not, welcome. It's really nice to see you come out on a Friday. I know it's a lot to give up, but Friday happens to be the best day for STEM students because you guys are not in labs, you're not in math class. So we hope to have more events on Fridays if you guys are cool with that. Today we have Patricia. She's our STEM CGCA. So you might see her in her classroom doing presentations or announcements for the STEM program. And she's also going to be presenting with me today. Okay. We're going to kind of stay here because the microphone is here too. So today we're going to talk about a couple things, and most importantly, engineering. A lot of students come and they say, I want to major in engineering. Cool, what kind of engineering? And then there's this like question mark, right? Because there's so many different, the field is so diverse. There's so many different industries that you can be in with just having that background in engineering. So we're gonna talk about what is engineering, some engineering industries, not all of them because we know that there's like a bajillion out there, right? We're gonna talk a little bit about job opportunities. Then we're gonna talk about transferring as an engineering major. And everything is in general terms. I do invite you to come and make an appointment with me if we haven't made a student educational plan before, so that we can do it specific to your major, your specific major, engineering major, your specific school that you want to transfer to, and then also based off of where you are in the math and the sciences, right? So we're going to talk in general terms today, so don't freak out. And then at the very end, we're going to have the engineering panel. We do have a few questions that we've asked them to prepare for, but then if we do have time, we're going to go ahead and have you ask your questions, because I know you guys had some really good questions from the RSVP. So we'll go ahead and give you the opportunity to do that if we have time. How's that sound?
Sounds great.
Great. So we'll go ahead and start with them.
Okay. So like Angela mentioned, the engineering field is very diverse. So I pulled up like a very broad definition of what is engineering. And essentially engineering is the application of scientific knowledge to solve problems and implement solutions. So in coming across this, there's various disciplines and subdisciplines within this field. For this presentation, we narrowed it down to the four like main categories. Not to say that they're the most important, but they're the ones that are the recognized ones within the field, the major ones. So before we get into that, I wanted to talk about a few organizations in regards to engineering. So we have ABIT, it's the accreditation board for engineering and technology. They're responsible for accrediting college and university programs in the disciplines of applied science, computing, engineering technology at the associate, bachelor, and master degree levels. I went ahead and put a link to the website. It's great to look up schools that you're interested in, seeing if they're accredited by this organization, because depending on what engineering field you're interested in, they may require it more than others. Another important organization is the ECPD, which is the Engineering Council for Professional Development. It's also another professional body dedicated to the education, accreditation, regulation, and professional development of engineering professionals and students in the United States. There's approximately 3,700 programs at over 750 colleges and universities in 30 countries. I, again, went ahead and put the link that you could use to research any of the universities you're interested in, or just to learn more about what this entails. These two organizations will be coming up a little bit later because I'll be talking about them right now. So the four main categories of engineering that we decided to speak about today are civil, chemical, mechanical, and electrical engineering. So civil engineering is responsible for not only overseeing and managing the design process, but also supervising construction and helping maintain the finished project. So it's a very broad definition about the field, but I just wanted to provide, like, for students who aren't sure if they're interested in engineering, a broad definition for each of these categories. We'll go more in depth once I complete this slide. So for chemical engineering, they work in a variety of settings, and the tasks they perform may include everything from constructing different compounds to processing chemicals to advising regulators on laws that make people safe. In regards to mechanical engineering, it's a responsibility for the design, development, building, and testing of a wide variety of different thermal and mechanical devices. And then for the fourth one, electrical engineering, it's utilizing the principles of electricity They design power grids, computer circuits, software programs, and power supplies. So going more into depth with civil engineering, I looked up the annual wage in California based on last year's, 2016, and it was 104,570, with most people making between those two ranges of 63,930 and 148,340. I listed some of the duties that are entailed as a civil engineer, so you can witness those right there. The list goes on. That's just a few samples. And then a sample of reported job titles. Oftentimes, if you're an engineering major, it doesn't mean your title is going to be just engineering. It could be like a city engineer, civil engineer, very more specific. So it just provides more examples of what fields could fall into it, and then it gives you the opportunity to research specific titles, contact people within those fields, and see how they describe their daily job. So, and then civil engineering, I looked up the education. So it requires a Bachelor of Science degree in civil engineering. Employers typically prefer you to be in a curriculum that is accredited by ABET, that organization that we earlier covered. Some of the skills listed are knowledge of physical science and engineering principle, ability to work as a member of a team, and knowledge of computer applications to engineering and design. And then there's also lists of places to work. It's a very broad list of it. So like utility companies, doesn't list specific organizations. For example, it doesn't say like, oh, Tesla, but it gives you like a general like outlook of where organizations could be located. The next one is chemical engineering. So this one has the average annual wage is 104,080, and most people make between 53,130 and 158,790. Again, I listed some of the duties entailed in there. It's good to check out to see whether you're interested in doing these type of tasks in your daily life. Sample of reported job titles are also to be found in your sheet. And then the education varies a little bit. You have to get a Bachelor of Science in Chemical Engineering. And so a considerable amount of learning takes place on the job. So they want the foundation of the learning, but a lot of the education that they bring to you is when you get the job itself. So that's why it's sometimes helpful, or definitely helpful, to have internship experience within these locations. Some of the skills associated to this is knowledge of physical sciences, especially chemistry and engineering principles and methods of engineering. They also value the ability to communicate effectively verbally and in writing. Some of the places to work include petroleum, chemical, rubber, plastics, and pharmaceutical manufacturers within that. The third one is mechanical engineering. Last year, the average annual wage was 102,650, and most people making between the 59,570 to the 155,780. So as we can see, like from the just 3 previous examples, it seems like a very profitable career. So it's a good outlook. And then some duties are also listed in your sheet, as well as a sample of reported job titles like application engineer, designer engineer, design maintenance engineer. The education for this field is a Bachelor of Science degree from a school whose curriculum is accredited by the Engineers Council for Professional Development. So that's the second organization we covered earlier. And it plays a big role. Some areas of engineering value certain aspects, so to be involved with organizations, to be aware of what's out there, what can you be a part of that helps you as a future employer, shine out. So some of the skills are listed as knowledge of physical sciences and engineering principles, ability to communicate orally and in writing, and then knowledge of the principles of solar energy and of solar systems designs. I also listed some of the places to work. And then last but not least, it's electrical engineering, with the average annual wage being 115,290, and most people ranging between 65,940 and 167,640. Duties are listed as well, so it's research, design, develop, and then a sample of reported job titles that could be found in association to electrical engineering. So the education for this particular engineering field is a Bachelor of Science degree in electrical engineering, and the school has to be accredited by the Engineering Council for Professional Development. There's also other listings, like you can get entry-level jobs with an associate's degree. So it's a possibility, and it's further listed in the education. The skills include knowledge of mathematics, physical science, and engineering principles, knowledge of electronic and electrical theory, ability to analyze data and make decisions based on the data. Some of the places to work for electrical engineering is power, light, and energy system companies, communication companies, construction firms, or petroleum exploration companies. And then here are some additional categories that we, because of time, we didn't cover. But if the 4 didn't pertain to you or didn't strike your interest, you can always research these additional ones.
So those other areas can be covered with some other engineering degree. So for example, a biochemical engineer doesn't necessarily require a biochemical degree, engineering degree, right? You can go in as a chemical engineer and then go into that industry. Okay. So there are a lot, robotics engineers as an example. We do have a robotics engineer coming in that's going to do a Google Hangout with us today. Her background is in mechanical engineering. So this is these are other areas, and that's why we focus on those 4 to just get you to start thinking about, okay, what can I do? Which type of engineering am I most interested in with that background? And then with whatever degree you decide to go into, you can definitely start working in any of these other categories or industries of engineering. Okay. So I know that was a lot of information. Now we're going to transition into transfer. So just to get an idea, shout out what kind of engineering you're all interested in doing in the future. We'll start on this side.
Mechanical.
Mechanical?
Mechanical.
Mechanical?
Civil.
Civil?
Well, I have a question.
Yeah.
She mentioned that in engineering, there's an AA.
Yes.
Does this school offer that?
No, we do not. Yeah. And then you were civil, and you were civil.
Mechanical.
Mechanical.
Civil.
Electrical. What about that? Mechanical.
So there's a mechanical and bio.
Okay. Computer. Awesome.
Mechanical. Electrical.
Okay.
Electrical.
Okay. So it sounds like we covered almost everyone with those 4 main categories. Aerospace can be, you can go specifically into aerospace, or you could do mechanical and then work into the aerospace industry. So there's lots of electrical engineers too. They need electrical engineers in the aerospace companies. So that's the beauty of being an engineer. You can do one thing, have a background in one thing, but what really shapes your experience are your internships and maybe shadowing, doing research, right? It's very easy for us to get stuck. I'm going to be a mechanical engineer, and therefore I'm going to be doing mechanical engineering work. And a lot of times we do think that way, but definitely start thinking broadly. You saw what other example titles there are when it comes to job descriptions. So it's not too early to start thinking about those job descriptions, right? If you see a job description, what kind of engineering degree is required? What kind of experience is required to get into that job? So you're going to earn all of that, if not here at Mission. Hopefully when you transfer, you'll get that experience, and then once you graduate, you're ready to go. Okay. So when we talk about transfer, there are many different pathways to transfer. Many of you have already met with me, and that's great. But just to recap, remember that in order to transfer, you do need 60 units at the very least for the UCs and the Cal States. Today we'll be primarily focusing on the UCs and Cal States. Private schools are a little bit of a, they're kind of like a wild card. Although they only require maybe some schools 30 units, they are really looking at your major preparation or those major requirements, okay? So general education is important. You would either follow the CSU GE-BRA or IGETC. And then once you have, in addition to that, you have your major requirements, which today we'll go into looking at assist.org. And that can help you in researching your major requirements specific to the school and the specific area in engineering that you're interested in. And then once you complete those and you have 60 units for the most part, right? there's always a star when I talk about in general terms, then you're ready to transfer. Surprise! Doesn't matter which engineering field you go to, you still need math and science, specifically in physics, right? So all of you, even if you have different engineering, you have electrical, you have mechanical, you have even computers, a lot of them overlap with the math. You know, if you've met with me, you know how much math you have, right? And the physics as well. So when we talk about degrees in engineering, a lot of times we don't have an associate degree in engineering here. I know some other schools in the district have like a pre-engineering or like a drafting degree, which allows you to do more technical work. But here at Mission College, the best major for you to follow is going to be the associate degree for transfer in math, okay? Because you have so many math classes to take. For a lot of you, you'll be taking Calc 1, Calc 2, Calc 3, linear and differential equations, in addition to your physics classes. So, and we'll go over that in a second. So here at Mission, it would take about 2 to 3 years for you to complete your requirements for the AST, which is Associate Degree for Transfer in Mathematics, which allows you to graduate from Mission College, but also allows you to transfer to any Cal State that you'd like to as a math major, or prepare you for an engineering degree as a transfer. So you're kind of hitting 2 birds with 1 stone. You get a degree, which is kind of nice. You put in all that work, all that math, right? You kind of want something as you walk out the door. I would highly recommend pursuing this associate degree for transfer in mathematics. But you know, for some students, it doesn't work. And that's why I do encourage you to come meet with me to talk about whether or not this is a good fit for you. And chances are it will. Now, once you do transfer over to the university, you'll be getting your BS in engineering, depending on what kind of engineering degree you want. For the most part, at the university, it'll take about 2 to 3 years, mostly 3 years, just because you have so many upper division courses that you will be taking. If you finish the entire math sequence, all the science sequences here at Mission, it'll be a lot less time at the university, which we know is more expensive, right? If you were to leave, and there are some schools that do accept without completing a degree, without completing all of the prerequisites, there are schools that do that, but guess what? You're gonna be taking the same classes at the university. So it's really a matter of what's most important to you. Is it more important for you to complete all of the courses here at Mission, save a little bit of money, and before you transfer out? Or do you just want to go to the university? And that's cool too. Whatever it is that you is priority for you, we support it 100%, but that is your decision. Okay. So a lot of people will tend to, the majority of people that I work with will tend to finish the majority of those classes. Maybe they have 1 or 2 math classes that they haven't finished yet, and some schools will accept them. But for the most part, you'll still be taking those classes because chances are those classes are prerequisites for the upper division classes. So you got to work on those first before you even start the engineering courses. Okay. So it's really important to take note of that. I know it's a really long time. 3 years to transfer is a really long time, but it'll definitely prepare you the most once you complete these courses, okay? Once you are done with your bachelor's degree in engineering, you can get a master's in science in engineering, and that's usually 3 years at the university. Okay? And then we do have 1 panelist who has a master's degree, so we can ask questions about that if you have any. And then a PhD is usually for students who want to do research in the field, not so much be hands-on or working in the field. They might be consultants in the field, or they might be teachers to teach at the universities for engineering. So most of the time, they do research and teach at the same time as part of their duties in academia. Any questions so far about your pathway, degrees in engineering? Cool. So this is a really general overview. Yeah.
I know it's a general overview, but I didn't know that there's a program talking about a tag.
Mm-hmm.
I know specifics for different schools, but it's still like CC or do you get priority?
Yeah. So that's a great question. So UCs have a program that's called Transfer Admission Guarantee. How many of you have heard of Transfer Admission Guarantee? Well, a lot of you, about half. So Transfer Admission Guarantee is a program that allows you to guarantee your spot into a UC. All the UCs participate except for UCLA, UC Berkeley, and UC San Diego. But all of the other schools will participate. If you Google UC Tag Matrix, it's this beautiful spreadsheet. I love spreadsheets. It's a grid of what the requirements are for each of the participating UCs. And so they tell you a specific GPA that you should have in the major. And some of them are really specific for engineering. So if you are applying to a major in the College of Engineering at UC Irvine, they want you to have actually a higher GPA than some of the other liberal studies, humanities, social science majors. So and they will tell you that criteria on that spreadsheet. And then there are also some exceptions. Some schools will say, you know what, we have too many engineering majors that are applying, or biological sciences majors applying to our school. We won't accept tag for that major. Okay, so it is case by case, but it is definitely a great tool to use. And usually the application process for the UCs is in November, right? If you are about to finish your last math classes this spring and graduate with us, you would be applying this fall in November to transfer by fall 2018. If you are thinking about tag or to tag a school and you have the GPA, you have all of the major requirements that they want you to complete before transferring, then you would be applying right now. September 1st to the 30th, before the actual application process, that's when you submit your tag. So you have the month of September to do that. The dates don't change. So September is tag, November is UC applications. If you keep that in mind, and then it's always a year in advance, or you can always come and ask me, that's fine too. Those are the deadlines and they don't change. Sometimes I extend it, but generally they're the same. But yeah, great question. All right. So I talked about the associate degree for transfer in math, and these are the requirements. So when you add these major classes plus your general education classes, right, that would equal more than 60 units, I'm sure, and your associate degree for transfer, which allows you to transfer towards the Cal States in math, but also prepares you for your major in engineering. So I wanted to highlight this because a lot of students don't know that they're actually eligible for a degree. It might be this, or we have another one. So again, we can talk about that in our one-on-one meetings. So if you notice at the top, we have 3 classes that is required. That's Calc 1, Calc 2, Calc 3. How many of you have taken at least one of these classes? Yeah, yay. So we have those 3 classes. That's already 15 units. And then from list A, you have linear algebra and differential equations. You only need to select one from that group. But I know that most engineering majors will have to take 270 and 275 anyways. So if you notice on the bottom, the list B, you can select one of those courses, either Computer Science 439, Computer Science 440, or Math 227, or you can actually use the other math class that was not used from list A. So if you took Calc 1, Calc 2, Calc 3, linear algebra, and differential equations, you already qualify for the associate degree for transfer in math, as long as you completed your general education. Does that make sense? Yeah.
Quick question. Is that only acceptable here, or do you take those linear in law that you get the UC or CSD?
It would be at the community college, yeah, typically. And then for those of you who are in computer science or some mechanical engineering majors, may have to take some programming classes. So if you take programming in C and C++, which if you're taking C++, you would have taken programming C because it is a prerequisite, then you can use that instead of if you don't take the linear or differential equations, but you must take at least one of those. Okay. So this is why, as you can see, this is why this is most recommended, because you get to graduate. You spent so much time, all of those, sweat, blood, and tears in math class. You deserve to get that degree. So when you do meet with me, let's talk about that and see how we can get you to graduate with that degree. All right? Any questions about this? And this is also in your slides too. All right. So I wanted to do kind of like a spotlight on mechanical engineering because I think like 50% of the room is mechanical, right? If not civil. So I wanted to show you the difference between transferring to UC and transferring to a Cal State. So a lot of students, they're like, I don't know where I want to transfer, and that's fine. That's why we're here, to help you figure out where you might want to transfer to. So the most common schools that people would like to transfer to is Northrop and UCLA. Why? Because it's close to us, right? And UCLA is prestigious, so why not? So one of the things, I gotta get closer so you can see. I want to show you what is the requirements for CSUN and for UCLA for mechanical engineering. So if you look at the handouts that was provided for you, you have these two sheets that are separate. I want you to pull that out. And these are directly downloaded from assist.org. How many of you have used assist.org before? Yay! So for this, we looked up, the first one is, we looked at CSUN. I know I want to go to CSUN. I know I'm transferring from LA Mission College, and I know I want to be a mechanical engineering student. Okay, so then it provided us a report that shows us the courses that are equivalent to our campus. So it doesn't leave you, you don't have any questions about whether or not these are the right classes for you to take. Okay, and then the other one, same thing, except I looked at UCLA, and then I know I'm transferring from LA Mission College. Side note, if you are taking classes at Valley or Pierce, you can look that up too. So if for whatever reason the class doesn't fit into your schedule here at Mission and you wanted to take it at Pierce, you can. But we can work around that. But that's usually how we compare whether or not the classes you're planning to take will be equivalent to the school that you want to transfer to. So if you're applying to 4 schools, or maybe 4 UCs, 4 Cal States, you're going to have 8 different sheets to follow. But if you compare them, like what I did here in the sheet, you can kind of see the similarities and the differences between Northridge and UCLA. So what I've done is I've stacked them. And if you've met with me before, you know what I'm talking about. I've stacked these classes. So if you think about each column as a semester, that's how many semesters or terms you would be taking the core classes. This is not including the general education, because the general education we can kind of squeeze in between. You can work on that at the same time as your core classes. But you can see that if this was your first semester, I would recommend that you start at trigonometry and chemistry. That way, you move into the next courses, which have those prerequisites. For example, the pre-calculus. Before you take pre-calculus, you got to take the trig. And then before you take Chem 101, you got to take the Chem 65. So all of these classes are in sequence as I kind of like to compare it to like playing a video game where you unlock the sequence or you unlock the achievements, right? So you can't pass or go to the next level until you've completed these missions or these goals, right? So that's kind of how I see it. And so the top one is the Northridge one. And so you can see you're taking about 1 or 2 core classes at the same time, and that's pretty manageable. How many of you have taken 2 core classes at the same time before? And how was it?
I'm taking 3.
3? How was it?
I just started.
How's it going?
It's
Too. So you can see from your peers that it's doable. Does it take a lot of sacrifice?
Yeah, I feel like you gotta work. If you work minimum amount of hours, or else you're not gonna be able to get all of work done.
Right. It's a lot of work, right?
It's a lot, yeah.
Yeah. And for those of you who are taking 2 at the same time, pretty much the same, right?
It's all your focus.
Focus on that, plus you're juggling maybe your other GE classes at the same time, right? So it is a lot of work, but you guys already knew that, right? Going into this major. So when you compare that with UCLA, I've highlighted the differences. So this is the same major. These are the same classes here. They're all offered at Mission, but I've highlighted the yellow ones because those are different than what CSUN wants. So if you're only focused at the Cal States, chances are it's going to be very similar to CSUN with the exception of maybe the Cal Polys like Pomona and San Luis Obispo. For UCs, they're definitely going to want you to be even more prepared by taking all these other classes. So an example is like the computer science. For mechanical engineering, you actually need to know computer science for UCLA, whereas CSUN, you might have to take one eventually over there, but it's not as specific as UCLA's requirements. Same thing with physics. The minimum requirements to get into CSUN is physics 37, physics 38, but we know that UCLA is going to want 39 also. So if you know that you're applying to just a Cal State's, great. But if you know that one day you might change your mind and you might want to, you have the grades, you have experience, you know that this is the right field for you, and you want to transfer to a school like UCLA or any of the UCs which do require more classes, then you're going to have to plan to take everything. Because if you plan to prepare for UCLA, you're pretty much preparing for all UCs and all Cal States, right? So I always ask our students to think about the school that you really want to go to. Like, even if, we know it's a difficult school to get into, it's very impacted, but let's prepare for that so that you can prepare for all the other schools. Okay. So this is just a snapshot of what I do with you when I meet with you in appointments, but also to help you start doing the research on your own. Y'all are science majors. I know how meticulous you are with notes, because you gotta be, especially in the labs, right? I know that you're able to do the research on your own and come and see me and we'll talk about it. We'll see what the best fit is for you. And then the other part of selecting a campus is what services are being offered at that school. Where do their alums go to work, right? Later in a bit, we'll hear from some alums from Northridge, Pomona, and Berkeley. And you'll see what their experience was like and how important it is to gain that kind of experience in addition to the courses. It's one thing to get good grades, but it's also another thing to get relevant experience. Okay? Any questions about this? I do want to point out on the assist page that we have in front of you for UCLA, there's really good information on here at the very beginning that tells you what the minimum GPA is. So the minimum GPA to transfer as of this past fall was 3.4 GPA. If you didn't meet that, you were probably not considered for that major. Okay, so it's really important to see what that selection criteria is, and then sometimes they'll even be specific, like you must have these courses in order to be considered for the major. If you don't, again, you get cut out from the list. Okay, so it's really important to pay attention to those fine details, and every school will have them, and as well as like tag information and then GE information too. Notice that here it says that partial IGETC is not accepted for UCLA. Why are we using IGETC for this school? Anyone know?
Is it at the UC system?
Mm-hmm. Yeah, so the IGETC is to allow you to transfer to, it's a general education pattern that is acceptable for both the UCs and the Cal States. So again, if you're applying to both UCs and Cal States, IGETC is your thing. That's your general education pattern. And then just make sure that you take note of these things. There are some UCs that allow you to do partial IGETC, but for this particular major, and I think as it becomes more and more impacted, meaning that there are a lot of people applying, they start putting these restrictions. So it's really important to pay attention to the bolded lines, right? And then sometimes they say, these are required, and these are desired or strongly recommended. What does that mean? I'll give you a higher chance of getting accepted. Yeah, they will give you more favor if you completed that versus a student that did the bare minimum, right? Plus, if you complete those, you're much more prepared than going into, than as if you didn't take those strongly recommended or desired classes. So those are terms that you want to look out for and pay attention to, because it's not just like there for fluff, it's there because it's like a warning or something to prepare you with, okay? Cool. So one thing that I did want to bring to your attention is engineering versus engineering technology. So there are majors, if you look on Assist and you just type in engineering, there are a bunch of different majors that's going to show up. Some of them say like mechanical engineering, electrical engineering, but some of them will say engineering technology. And so a lot of students will consider that as an alternative major, but do some research about it. I just did a brief overview of what that is because it might be a good alternative for some people, right? So they're separate, but they are closely related. So the curricular focus is a little bit different. So engineering programs often focus on theory and conceptual design, while engineering technology programs usually focus on application and implementation. Engineering programs typically require additional higher level mathematics, including multiple semesters of calculus, calc-based theoretical science courses, while engineering technology programs typically focus on algebra, trigonometry, and applied calculus, and other courses that are more practical than theoretical in nature. So what does that mean? I know it's like a bunch of stuff, words. So they're theory-based for engineering, so that you can, look into the future and see how things are going to work. Versus the tech programs, engineering technology, they're more applied and doesn't dig that deep into the math. There is some calc. I think a lot of the programs that we look at is Calc 1, and then that's probably the highest level of math that you would need before transferring it. Yeah.
So, for example, say a mechanical engineer versus an AP mechanic.
That's an AP.
And airframes and power plants.
I'm sure if we looked it up, yeah. So usually what happens is we have a project manager or an engineer that is in charge of the project, right? And they are like a certified project engineer. And then they usually have a team of people that is working with them. And one of those people can be a person who has studied in engineering technology. Okay. So, but there is a way for you, if you did engineering technology, to still become a project engineer. It just takes a little bit longer in the process to be licensed. Okay. The career paths, graduates from engineering programs are called engineers and often pursue entry-level work involving conceptual design and research and development. Many continue on to graduate level work in engineering. Graduates of four-year engineering technology programs are called technologists. These professionals are most likely to enter positions in sectors such as construction, manufacturing, product design, testing, and technical services and sales. Those who pursue further study often consider engineering, facilities management, or business administration. So it's more of the management side of things instead of taking ownership of the actual project itself. While topics of core classes in both programs seem similar, engineering technology classes will emphasize the application of engineering techniques, and the engineering courses will focus on the development of concepts. So that is the main difference between two, techniques versus concepts. Okay. How well are we going to do it, and how are we going to do it? Those are completely two different things. I think a few of you are familiar with ASSIST, right? So, fun fact, this was my best friend when I was in community college. I looked at it every day, and I don't know why. It just made me feel better about like making progress in my classes, doing research on different schools, which is probably why I'm a counselor now. I was also a chemistry. Didn't like being in the lab all day, so I decided to change things up. But knowing what you don't want to do is just as good as knowing what you do want to do, right? So that's what this is for. So I'm going to show you how to use ASSIST a little bit more in depth, and then go over the other handout that we have. So let's say we were interested in civil engineering. I'm going to click on this green button that says Explore Majors. This is usually best for students that don't really know where they want to transfer to. If you're open to transfer, you're open to moving away from home and maybe exploring a different part of California. This only pertains to the UCs and the Cal States. But it gives you an idea of where these majors are or what majors actually exist. So if you click on majors, the green one, and then you select an area of study, engineering. Then there are different disciplines that we can choose from. There's agricultural, architectural, aviation and aerospace, bioengineering, technology. This is a good way for you to start looking at what's out there, okay? What kinds of majors. And for me, that's kind of like exciting, right? To see what kinds of majors are there and what can I learn and what classes are required. Look, there's nuclear engineering and then there's those technology majors as well. So for today's purposes, we talked about mechanical a lot. Let's talk about civil engineering. So let's click on civil. And so this is going to show us all the UCs and Cal States that offer anything related to civil engineering. So notice that this one, they're all abbreviations like SLO, CP, is San Luis Obispo. We have Chico State right here, and then I forgot which one. Fresno, Fullerton, Cal State LA, Long Beach, CSUN. So if you're looking like how close you want to come be or how far, UC Berkeley, UC Davis, UCLA. So, and then there's also civil engineering programs with a specialization or concentration in environmental engineering, civil, general civil, or geospatial at Cal Poly Pomona. So this is a good way to look at it. And then UC Irvine has one too. Let's take a look at one. Which one do you want to take a look at? CSUN. All right. So we're going to click on our community college. This is also very helpful for students who have gone to other community college before coming to Mission too. So you can definitely, if you went to a school up north and you wanted to see which ones of your courses will qualify for the same courses to transfer out, you can check that out. But here we're going to select Mission, and then it's going to bring us some information. You can actually look at our neighboring community colleges too. So let's say that math class doesn't fit your schedule for that one semester and you wanted to take it at Pierce or Valley or College of the Canyons, you can download this also and look at the major preparation articulation. So this is what we're looking at. And we're just going to click on major prep and it's going to bring up this, which is exactly what you have in front of you, except this one is specifically for civil engineering. Again, we have important things to take note of here, but also what are the requirements. So left-hand side, CSUN, right-hand side, Mission College classes. So we know that something that's different from what we looked at before for mechanical requires biology or geology. Okay? And then the math is a little bit different, and then the physics is the same for CSUN, civil engineer 3738. So it's kind of how you read it. I know sometimes it's a little bit difficult to read because they put like if, or, and or. It just gets a little bit confusing, but that's what we're here for, to help you understand it a little bit better. But let's take a look at another major. Or let's say we're interested in, we have someone who's, let's see. Let's say we have, what do you guys want to look at? Nuclear? It's a different one, yeah. So then we have that at UC Berkeley only. But notice that it's like computer engineering and nuclear engineering, electrical engineering and computer science and nuclear engineering. So it's kind of like a double major because there are different applications, right? You can apply electrical engineering to the industry. And so, but if you wanted just straight nuclear engineering, you look at UC Berkeley. UC Berkeley is really interesting because they're one of the oldest UCs, they are the oldest, but also they have very specific requirements for their general education. So this is also one of those schools that has specific requirements that you really want to read the fine lines. So right away you notice that a summer class is not considered as work in progress. It must be taken by spring before you transfer for it to be considered. Only applicants who have completed 100% of these required courses will be considered. So if you don't complete those courses by spring, then you would not be considered for the major. And So then there's like these core courses for admissions. A lot of this doesn't make sense, but when you scroll down, it shows you the equivalencies. Again, we see the strongly recommended courses. I say just do it as if they were required if you have time. Because if you don't take them, you're going to end up taking it over there. And then it also tells you about how they base their selection criteria. So for them, GPAs are a really big requirement for them. But one of the things that's interesting is that the College of Engineering at UC Berkeley does not recognize the I get C and strongly discourages students. So it's kind of like, well, I'm applying to all of these schools, but I'm also applying to this particular school that doesn't accept I get C. But if you actually look into what the general education requirements are for UC Berkeley, they do kind of match the I get C. But you have to pick and choose those classes that they will take for general education. So that's where we come in and we help you pick those classes for general education. Yes.
So not all UCs require the I guess.
They may require for a different major, but for this particular major, they won't. Yeah. So let's say you get I get C certified by the time you leave, you finished it, and then you transfer out to Berkeley, and then they look at your general education. You could still be admitted, but they might have you take additional classes. Whereas if at a different UC, if you completed your I get C, that's a promise saying that you don't have to take any other lower division GE courses. So that's where it gets a little bit confusing, but with our help, we can hopefully help you navigate. And that's why it's super, super important to identify as early as possible. If this is a school that you want to go to, start the research right away. Make sure that you have a strong list. And then, as time goes by, every semester we check in, you would check in with me. We can knock out some schools. You know what? I visited the school. It's not the school for me. I'm not going to prepare for that school anymore. And then that could change your plan. So your plan that we have, some of us would created a plan together. It's not set in stone. We can move some things around. Things happen, life happens, and we want to make sure that we're doing it according to your plan, not your friend's plan, not your cousin's plan, but to what it is that you want to accomplish here with us. All right. So hopefully you're able to look at this. Again, it shows you the comparisons, right, of all the courses that are required. Yeah, Berkeley is one of those schools that are different. Cal Poly Slow is a little bit different also. And then sometimes UCLA, but they're pretty straightforward. Okay. Let's do one more. So let's think of a major that we didn't talk about yet. We have aerospace, right? Let's type in aerospace. Or even aero, and let's see what comes up. So then it's going to show us anything that has those words in it, and then you can look at the schools. So here we have some UCs and SLO, San Diego State, San Jose State, and Long Beach, which have aerospace engineering. So every school has their own engineering program, but not all of them have the same one. So aerospace is a little bit more specific, and so you can find that. SLO has a concentration in aeronautics and a concentration in astronautics. That's kind of cool. And then UC Davis is a little bit different. It's aerospace science and engineering. So if you wanted to learn more about what the differences are within the schools, because all of these schools sound great, right? They have your major, great. But how do you determine what school you want to go to? My recommendation is that you actually go to the school's website. So let's say I go to Cal Poly SLO's website in the College of Engineering, and as if I was a student already there. What kinds of classes am I going to be taking as a student in aerospace engineering with a concentration in aeronautics? So that's the level of detail and research that we can work on together, but I do encourage you to start looking at it. If you want to print it out, bring it to me and I can help you figure it out. That's great too. But it is like two-way street. I'll give you information, you give me information, and we'll work together on that. But that's one of the best ways for you to figure out which school you want to go to. Because especially for you mechanical engineers, you have lots of schools to choose from. But what is your determining factor? Is it being close by? Is it the research being done there? Is it the internship opportunities at that school? What is it? or is it the classes that you're going to be taking? What is it that sets that school apart? Not just by the name, not just by it being close by, but what does that program offer for you? All right. We're just going to go ahead and get started. These are our students at LA Mission College, and I think a lot of them are in different places right now. So some of them may have just started thinking about engineering. Some of them are almost ready to transfer as an engineer. They're all at different timelines, but any insight would definitely be appreciated. So we're just going to go ahead and do introductions. Let's do name, your degrees, where you graduated from, the company that you work for, and some of the duties and responsibilities in your current position. So let's go ahead and start with Jennifer.
Hi. So my name is Jennifer Liu. I studied mechanical engineering at UC Berkeley. I'm currently working for Tesla, building the but I've been working on Model S and Model X electric cars, if you have not heard of Tesla before. My primary duties are, I guess you would call me like a robotics, although my title is a manufacturing equipment engineer. We program robots to build the car. All these robots have what we call end effectors that can pick up the part, weld the pieces of metal together, apply adhesive to it, and all of that pretty much builds and fuses the metal pieces of the car to build the frame of it. Everyday things that we're problem solving is like today we had an issue where the robot kind of freezes up every once in a while, and it's only during this process where it changes the caps, and it's because we have to figure out why. It's because I'm suspecting it's because I'm using the wrong signal to check for certain conditions to allow it to do that process. So every day I'm trying to solve problems that prevent us from building to the robots.
Awesome.
Thank you. Let's go to Joel.
Hi, I'm Joel. I'm a product development director for Applied Medical. So we are a manufacturer and designer of laparoscopic surgical equipment. So my day-to-day or my function is building a team that can help in finding a need for a specific surgery or specific need or within surgery, and developing a device for that, and then bringing it into manufacturing, qualifying that manufacturing process, as well as releasing the product to production. A lot of my time is spent mentoring new engineers, as well as new engineering managers, and a little bit less on the actual design work now, but always there to help the new designers.
Cool. And your degrees?
My degrees, I'm a manufacturing engineer and master's in engineering management from Cal Poly Pomona.
Thank you. And George?
Jorge Muralles. I graduated from Cal State Northridge in electrical engineering. Right now I'm working for NAVAIR, which is part of the Department of Defense. I'm an electronics engineer. Right now I'm just supporting the team using different software that they have, different programs running radar signals, and I'm also using MATLAB to kind of translate those outputs into a new system that we have. So right now I'm just supporting them in doing that.
Thank you. And Michael?
Hi, my name is Michael Perez. I'm a proud Matador from Cal State Northridge, graduated with a mechanical engineering degree with an emphasis in control systems. I work at Northrop Grumman in Palmdale as a packaging engineer. So although my major was in mechanical engineering, I serve more of a manufacturing and logistics function. So my day-to-day, there's 4 components that I have to really take care of and keep in mind. It's packaging, handling, material handling, storage, and transportability. So this goes from everything from large components, large assemblies that include aircraft, to treating fixtures, treating racks. And I also have a design component where I design PPDs, which are part protection devices, both for technicians and also for the aircraft. So whenever technicians and there's contact between the aircraft, that we make sure that one, our technicians are not harmed in any way, whether it's by special coatings or because there's sharp edges on fuselages, whatever. And also for the aircraft, because we want to deliver those aircraft to the customer in one piece, obviously. So in a nutshell, that's what I do.
Also, if you're not speaking, can you mute your mic so that it doesn't interfere? Awesome. Cool. So thanks for sharing your background and what you do. I think a lot of our students are really interested, yes, in the type of work that you're doing. Awesome. So a little bit about you. How did you decide on your major and your career? And when did that start for you? And then I guess we'll go backwards with Michael.
Okay. So growing up, I didn't really know what engineering was. To me, it was more just go to school, go through high school, get a job afterwards. It really wasn't until senior year that, because I was good at math and science, that engineering was even a possibility. So I went to CSUN thinking I'm either going to do business or engineering, but somehow I would be involved in both worlds. When I did decide on engineering, it was because I knew that growing up, I like to take things apart, not necessarily put them back together, but the fact that my curiosity drove my day-to-day. I remember one instance, I took apart my PlayStation, just curious, like it wasn't working. Okay, well, let me see what's in it. And after that, like the PlayStation, like I couldn't put it back together. But I knew that because I knew I wanted to know more about how things work, whether it's electrical components, mechanical components, even software. I knew that engineering was my calling. So I made sure that as I went through school at CSUN, that I would get mentors that already were involved in the field and were students at either junior, senior level, so that I know what courses to take, what professors to avoid, and how I can really get the most out of my experience at the university. So I would really say that my calling was mechanical engineering, because it really, I feel like it brings a lot of components of engineering, whether it's electrical, civil, automation. It brings it all together, and it really gave me a better understanding in my day-to-day also.
Cool. George?
So my story, I guess, is a little similar to Michael's. Growing up, just did not know what I wanted to do. I went to CSUN right out of high school, and I was undecided for almost 2 years, not knowing what I wanted to do, what field I should go into. I realized it was engineering because thinking back, it was when I was growing up, I would actually help my dad take, the car apart, change alternators, oil changes. And I was always curious, like he would do housework, Mickey Mouse's around the house, and I would always be behind him curious, like asking him, how do you do that? Like just wondering, like how do things work and how to fix and solve the problem. So it was until then when I realized, engineering is my thing. And I was always kind of interested in the electrical side. So that's how I decided to go into that. And then little by little, I understood, once I started learning the mathematics, the physics, and the actual engineering courses, kind of taught me, like, wow, I could really do something here. So it was sort of that way where it took me a little bit of time to understand what path I wanted to go down in. But once I realized it was engineering, so that's what I'm going for. So.
Awesome. Joel?
I took a little bit of a different route. I went to a technical high school. So going into high school, I kind of already knew that I wanted to go, or kind of was forced into going into a technical high school, and then learned how much I actually love engineering. Part of my high school, I had a manufacturing engineering course from like my sophomore year to my senior year. So as part of that, I went into Cal Poly knowing that I wanted to go into engineering and went from there.
Yeah, Jennifer?
So I had a similar to Michael, I think. I didn't know what I wanted to do. In high school, you don't really know what each field does anyway. My mom was like a preschool teacher and my dad is a maintenance worker. But when I went to college, I had started college as an economics major, thinking that I would do business. But then I realized at Berkeley, it has a kind of a different system where you start out as an undeclared major and then you have to apply again to go into the business school. I got scared because I got like an A-, and then I was like, oh, what are my other options? And then my friends were engineers. Like I did like a science and math program in high school because that was what the right track was at the time. And then I started taking more engineering classes. I took like physics and then I realized like I really enjoyed solving these kinds of problems. What I liked about it was in the other science and technical courses were like really just trying to solve a problem together. Like everyone was struggling and everyone just wanted to help each other out to solve these really difficult like real world problems. Then I started to take more like engineering broader courses, did some projects, and then realized I really just want to be hands-on. I really wanted to use what I've learned through the K through 12 system. You've been in school all your life, and I really just wanted to do something where I could see my work like out there, like it actually manifested into something physical. So mechanical engineering was the best choice for me at the time. And if I could go back, I would probably try electrical engineering. I just felt that I was a little bit too late, but in reality, you're never too late. You're just going to work a little bit harder to learn that, but it's always possible to do it. So, and I'm using a lot more electrical engineering now, which you can just Google if you really need to.
Yay, Google. Thanks. So what do you think was most helpful in obtaining your degree and also your job during or after college? And then we'll start with Jennifer again.
So what was helpful when I did my degree was probably having a pretty strong network of friends to do projects with. As I said before, you're really not alone when you're doing an engineering degree. Everyone is struggling to do it, and if you choose a program that does a lot of hands-on projects, that's just really awesome. And like you're all just trying to solve the same problem together. To help me at my job currently, well, before I came to Tesla, I worked for another company called Robotics. I was a packaging scientist for them, developing new products, like developing the bottle for a new like toilet bowl cleaner. That was one of my projects that never launched. But I really wanted to have that hands-on component again. And what has helped me out actually at Tesla was actually to learn the project management side from Clorox and implement it in Tesla in like a really rapid scale. Tesla's trying to achieve something that no other automotive company is doing right now. Trying to build a mass production car within like 3 years of really creating that concept. And that timeline and what you need to achieve within that timeline is a lot stricter than other companies. And I feel that the leadership skills that I developed at Clorox was something that I could carry over to Tesla. And it's really paid off. I got promoted within like the first year of starting at Tesla, even though I knew nothing about robotics initially, but I had strong like leadership and I could learn that stuff, or I could find knew the most find my information if no one else knew it. And I also wanted to like always experiment and take the time to just try it out myself. So I think those skills really led to my success as an engineer, not just the technical stuff, but the people and the leadership skills.
Awesome. Joel?
Let's see, the question was obtaining my degree. I would have to agree with Jennifer in that the people that you're going to work with within school are they're going to be the most helpful people to you. Utilize that as much as you can. You guys are going to struggle with each other, so might as well struggle together rather than by yourself. I was a commuter, so that made it a lot more difficult for me. But you end up making friends who are within your classes, and early on when you guys do transfer, I would really stay close to those people. They're going to be very, very helpful for your like senior design projects, for any projects within your classes, and making sure you work hard with them and not make them work for you. Another thing, so within my field, I think internships are really important. That's how I got my job. I was an intern there. I was an intern here at Applied Medical straight out of college, and got a job straight out of college. So that was very, very, very helpful. As many internships as you can get as you go through your time in school, the better. The more experience you gain with those internships, I think you're going to be more successful within your job function, whatever it may be. And stay curious, stay humble. That's really the way to go. That's what I see a lot in the people that I try to hire at Applied is the curiosity that they have really shows how much they want to grow within your company and really want to learn about what they have to do. And it's not just about the everyday functions of the job, but it's like how to grow as an individual.
Cool. George? I think your mic is muted.
Better? Can you hear me now?
Yeah.
All right, cool. Yeah, I would have to agree. Also, going through school, it's the friends you make. You'll see once you kind of taking the engineering courses and you're kind of moving up the levels, you'll see a lot of the same bases because they're all kind of going towards that same degree, whether it's electrical, civil, mechanical. They have to take the same type of courses. So little by little, you're going to see the same people. You make friends, you study together. A lot of times, what I would do is study by myself, really try to understand the concepts, and then study as a group. So then, if anybody else needed help, I can help them with what I understood, and then they would help me with what I didn't really get. So that helped me out a lot. The friends you make, the network, you know, the people that you talk to, the advice you give. Sometimes they know certain programs or certain, I guess, tips that you don't really know about going through your program that can help you out. So you look into that. You're like, oh, I can take this class and it'll count for such and such, or this class might be better for the route I'm trying to take. And also, yeah, working. I used to work full-time, I go to school full-time. I worked at an electronic manufacturing company for 2 years while I was going to school. So it's just the work ethic you develop and the knowledge you can gain from other engineers. It doesn't have to be in your same field. It could be, you know, manufacturing. It could be computer engineers, depending on what you want to be. The point is, you know, you kind of pick their brains and understand, and they kind of guide you along and mentor you. So it's that work ethic that helped me out as well in the work I'm in now, because you kind of understand how, I guess, a little bit of the real world is. When you're working, you have to kind of go to school. You have a little bit of both. You know, you have your feet in a little bit of both. So that helped me out.
Cool. Michael?
So, I mean, I knew engineering was going to be tough. It wasn't something that was going to come easy, but I made sure that I would have a work-life balance. So I was doing the study portion, but at the same time, making time for myself. So what does that mean with on-campus involvement? So a big part was SHIP, the Society of Hispanic Professional Engineers. I was also part of a salsa team. I was a performer and competitor with them. I was part of a fraternity. I was part of the new student orientation group, helping incoming students, whether it's freshmen, transfer, international exchange students. But really getting involved and expanding network that way, because in every social group that I was part of, I found that there was engineering everywhere. I wasn't the only student being involved. And in that way, yes, expanding my network, but at the same time, getting rid of the excess stress from all that studying. Like there were nights that I really would go without sleep. I know that I'd gone, the longest I would go was maybe 2 days without sleep. And but that does take a toll. Obviously, don't do that. But really, the network that you build will come through for you. The job that I received, so I graduated May 18th, 2015. May 19th, I was fortunate enough to have a job to go to the next day. And then 2 years later, with the job that I have now at Northrop Grumman, again, it was because of a network that I had after sending out 70 awesome applications to Northrop that role came through. So really, it's the networking. Yes, grades do matter, but it really comes down to who do you know and what sort of network do they have that can possibly help you out as well.
Awesome. Yeah, we do definitely try to encourage study groups and building that connection within the community, because you are the community that are trying to create together. What skills did you develop in college that do you think prepared you for the work that you do today? And then Michael, we'll start.
I'd say with the soft skills, leadership is a big thing. I know taking initiative on a project, being able to delegate certain tasks, public speaking, that's a big one. Because a lot of times either you'll be presenting whatever it is that you're working on, or there's customers that are coming and they want to know updates, what can they do to help out, speed up the delivery time. Technical, I would say the programming and really knowing like SolidWorks or CATIA. So with Northrop, we use CATIA, but in school we studied SolidWorks. Those skills, they're interchangeable. It's just the interface that changes, and I learned that on the job. But really having a background in some sort of CAD software, that really made all the difference. And then a little programming with VBA, because now I just do automation instead of programming cells to like grab data from other places. No, instead create a macro. It's so much more easier. So yeah, don't forget about the soft skills. Those really make a difference, especially if eventually you think about management. I'm sure Joel can speak on that too.
Thanks. George?
I would say pretty much just going through school and you're learning obviously the fundamentals of engineering, and the labs for me were a big thing. I really enjoyed hands-on work, building circuits, seeing how they work, troubleshooting, redesigning, redoing the math, trying to make them, trying to understand how you can make it a little bit better or efficient, actually work sometimes. But I would also have to say, as you're kind of going through school or going through the program, you're learning how to learn efficiently and how to love to learn. And not only that, but little by little, like over that program, you really start to think like an engineer, because there's so many classes that you take, so many mathematics, so many projects that you work on, and homeworks. Little by little, you're kind of looking at things. You're like, oh, you're trying to like break them apart, and that really helps out a lot when you're actually in the field. And so I would have to say that. And obviously, as Michael said, the soft skills, the leadership, the initiative. A lot of times you want to work on a project and everybody else is just kind of doing their own thing. That's when you take initiative and, okay, how about you do this, how about you do that, and try to make everything flow efficiently so everybody's doing something. And then you get to the end goal, to the problem solving, to the homework, to the project, whatever you have to do at an efficient rate in order to get the job done. And a lot of that's it does help out when you're out in the field, So I would say that really helps out a lot when you're kind of going through school and you don't really notice it. Little by little, you're like, oh wow, like I'm actually like thinking like an engineer. That's how I used to think. Because before, you think that's a different way, but after so many classes, after so many, you research so much that just becomes a thing. Like how does that work? right to my phone, Google. I'm just reading about it like, instantly. You know what I mean? And that's just kind of like how your head is kind of like programmed to do, because you're just so interested and curious to see how different things work. So that really helped out a lot. So.
Cool. Joel?
I think in terms of schooling, the technical side is something that will come to, or that everybody's going to get pretty much the same of. What you really should focus on really is the soft skills, like what Michael said. Really what I learned the most is working with others. You're going to have a lot of group projects within engineering. And even when you get into industry, you'll have a lot of group projects. And when you're at school, there's going to be those people that don't hold their own weight. And, you can tell the teacher, or you can keep on working hard to meet your deadlines. When you get into industry, there's going to be some people that are going to be like that still. They get weeded out really easily, but at the same time, you're going to have to meet your deadlines. You have a career that you're building. So being able to work with others and handle the challenges of your day-to-day is something you really learn in college. So when you do get that team member that doesn't want to help you out or isn't pulling their weight, you got to be able to learn how to speak up for yourself or for the team. Those are some soft skills that are really advantageous, and you should learn that quickly. Meeting deadlines, homework is not something that you just put off. It actually teaches you how to meet your deadlines, especially when you have stuff on top of each other. I always took a full load, and I know at times you're going to have 3 midterms in a day, or 4 different reports due on the same week. You just prioritize yourself and your time management skills. Those are very important once you get into industry as well. I think that's all I have.
And Jennifer?
I think looking back on it, what college sort of taught me was to have a healthy level of fear. Usually when I would take a test, I would be, even though I studied a lot and prepared all my notes, I was still being nervous about taking the test. And then if I didn't feel nervous, I usually get a worse score. Usually it was like I was too cocky, or I didn't know what I didn't know. I think that's what I had taken away. And I feel the same way at work now. Like if I tried to instill that to all the new team members, like you have to have a healthy level of fear where you're cautious and you want to thoroughly vet things and you want to test it to make sure that anything that you don't test will bite you back, which is what we see a lot in these projects. But you can't be so fearful that you just don't do anything. You have to have enough preparation where you feel that you can do it, but enough humility to realize you don't know everything about it. I learned that in college, and I think that I learned that especially here at Tesla. The other skills that have helped me a lot is just being super organized and not waiting for other people to tell me what to do or to know what's right. A lot of things that have helped me be different is I've organized a lot of structures that I felt were inefficient. Not only engineering-wise, but some processes at work. Like we had these paper forms that we were using, and I got us to go into electronic format, re-document everything, which is very difficult at a lot of companies. People don't document enough, but we've found a platform that we can try to organize it. So it's almost like my equivalent of cheat sheets that I had in college. So I'm trying to make cheat sheets for everyone, so they don't have to keep re-Google stuff that I've already found. So I think all this time, your previous experiences all just kind of add up, and there are really no mistakes. They're just always learning experiences.
Cool. So one of the other questions that we have is, what types of engineers or backgrounds of people that do you work with within your industry or even within your company? Because a lot of our students are curious, like, I want to do this, like mechanical, but then I'm also interested in electrical. but I also want to get in a specific industry. So what other types of engineers or people with background do you work with?
So I work with a lot of technicians and a lot of people who have gone through the Navy and military service as well. Some of the, like, my job specifically is to support maintenance. So we have a lot of people handling the parts to load them, and we have a lot of people who actually are on a day-to-day basis fixing the equipment. So a lot of the technicians have hands-on experience as an electrician or as a mechanic, and they are replacing nozzles and screwing down things and bolting things back together if they fail in production. So if you have a military background, like if you are a Navy nuclear officer, that's what some of my team, my coworkers have done. I think it actually teaches you a really good mindset to just get the job done. Some of the other people who work in my group, I do a lot of robotics, but we also do a lot of controls, which is using PLCs or programmable ladder controllers, or I'm sorry, I forgot what the meaning of the acronym is, but it's basically logic to control the machines. We also have process engineers, so they look at the workflow of the system. Like if we have to build the part within a certain cycle time, and for Model 3, that's going to be a minute. So you want to try to parallel the tasks as much as possible, so you're not waiting for other things. And the process engineer will look at, do you need 2 operators to load the part because one operator is bolting, the other one's something like, and how can we make their flow faster so they don't have to keep walking as much or put down tools. So there are other like process engineers as well.
Cool. Joel?
I work in a more interdisciplinary role. So we work with biomedical engineers, electrical engineers, mechanical engineers, manufacturing, industrial, computer science. So there's a couple aerospace engineers that are working for us as well. So it's pretty much every discipline except for civil that we have at Applied.
Cool. George?
Those are different, the majority is electrical that I'm working with right now, but there's also a physics major in there. I have met from other teams that are working with electrical, our computer engineers, computer science engineers, a couple mechanicals as well. So a lot of times what I've seen is you can say be electrical, but a lot of times you can do a lot of computer science stuff, and you can learn that and get kind of cross-trained in that. And so it's not just if you're electrical, you're only going to work with electrical engineers. At times, I think it's sort of like if your team is primarily electrical engineering based or electronics engineering based, you're going to see that a lot, but they all have to kind of talk together. They all have to be kind of in line with each other in order to make everything kind of flow through. So you're going to be, I think you will be working with different types of engineering. And when I used to work in manufacturing, there was a computer engineer. There was, I believe he was also a computer engineer, computer science, that was working in manufacturing. So you'll see a lot of kind of like cross training in that. That's what I've seen so far. So yeah.
Thanks. Michael?
So as far as their majors, a lot of them are mechanical, aerospace, manufacturing, and then as far as their roles at work would be packaging, like myself, industrial quality. That is pretty much it. But what I've noticed is that just because you majored in one discipline doesn't mean that you necessarily have to stay within that discipline. They are to some degree interchangeable, and if you would like that flexibility, I would recommend picking up a minor. I know I wished I had done that, and I didn't figure that out until after I graduated. That could have been an option, because it's easy to major in, like, let's say mechanical engineering and pick up a minor in electrical engineering. It's really only probably like 2-3 classes of a difference for that minor, because the prereqs, you've likely already taken them. So yeah, they really are interchangeable.
Cool. I don't think we talked about maybe what are some projects or cool projects that you might be working on in your day-to-day work, maybe recently or currently. We'll start with Michael.
For me, so I support well, there's several programs I support. The only one I can really talk about is the F-35. With that, it's more right now the transportability. How do we get the outflow of number of fuselages per day? How can we increase that? And then how are we transporting those either by ground, by sea, or by air to where they have to go? Like I said, that's as much as I can say.
Thanks. George?
I'm pretty much supporting the team that's working on a receiver for a Growler, and we deal with a lot of radar stuff. And I'm learning a lot, to be honest, about radar. I didn't really study a lot of that in school, so I'm learning a lot about that, reading up on it, and I'm just supporting them. They're running a lot of different types of software and different programs to simulate different situations. So right now we're just trying to analyze that, I'm trying to learn the actual program, and then I'm trying to convert that output using MATLAB and kind of analyze it using MATLAB, and trying to help out supporting one of my team members, and then under my supervisor who's kind of coordinating everything else. So as Michael said, there's certain things you can't really discuss, but for the most part, that's what I'm doing right now. So.
Joel?
Also, I'm in a product development role, so a lot of the stuff that I'm working on isn't in market yet. So I can't really disclose what those things are, but the cool things about what I've done in the past is being able to see your product in use. So because I work on medical devices, the time span to get a medical device out is fairly quick, at least within 1 or 2 years. So as engineers, we're able to actually go out into the field and see your products or my products that I've either helped in designing or helped in manufacturing being used on patients. So that's some cool things that I've done.
So my role right now is Model 3 safety. So we have a lot of automated equipment, and one big part of my role is to make sure that any operator or maintenance technician that goes inside this is safe. The robots themselves have software that kind of creates a virtual fence so you program where the robot is allowed to go and not allowed to go, and that often requires us to use 2D drafting software to map out the layout of where physically that robot is relative to the fence line or any fixtures that it interacts with, and then programming how the logic should go to make sure that robot stops moving when you're inside. So we have fail-safe mechanisms. So if someone unplugs a sensor or the gate stops working, it should detect the absence of a signal means that the state is unsafe. So if someone gate switch, it'll assume that someone's inside. So that's what we make sure that the robots, that any sort of moving system will stop. And then I'm catching people who are skipping things. So someone wanted to install a conveyor with parts and wanted to make it run, but there was no guarding in case that part fell off below, because things were sort of dangling. The part's supposed to dangle below. So we need to tell them that you're not allowed to move that conveyor unless you have guarding underneath. So that's sort of what my focus is right now. After all that safety stuff, it'll be trying to optimize the line and trying to make sure that like any problems with the equipment are going to be addressed and won't cause more problems than no more problems when you're resolving them than they initially caused. So yeah, that's kind of what I work on.
Cool. So at this time, before we ask our last question, I wanted to open up the questions to the students if they have any specific questions about their experiences in school, going into the major, and their careers. So does anyone have any questions? Yeah.
So,
You got to speak up so that the mic can pick it up.
I have a question for Joel, and that would be, how did obtaining a master's benefit you from just sticking with the bachelor's?
It's a good question. At the time I started working, or I finished my undergrad, the job market was pretty hard. So my decision to go into my master's was purely based on the fear of not having a job. So I wanted to have something to do. Fortunately for me, I got a job right after school, and I had started my master's already. So I didn't want to be the quitter, so I finished it. So I would say it can help you depending on your industry, but it's not necessarily necessary. At least where I work, it's really your hard work and your dedication that gets you to move up the ladder, and it's just your will.
I'm so sorry. This is more like a personal question. You guys look so young. How old are you guys?
I'm 29.
I'm 28.
I'm 26.
And I'm 25, so I guess I'm the baby.
Anyone else? Covered everything? We did have a few. On our RSVP, we had them ask questions about that they wanted to bring up. Let me see. What are the biggest struggles that you have faced to get into your field? I just kind of paraphrase that. So what are some struggles or a struggle that you faced going into the field? Anyone can pick up this answer.
Yeah, I started working at Applied 7.5 years ago, or 7 years ago. So it's hard to say what my struggle was then, but learning how to interview is a big struggle that I see constantly. Yeah, practice interviewing when you get to that time point. I interview people probably on a weekly basis, and some people have really good interview skills and some people don't, and you can really tell who has practiced those skills. That's your way to get your foot in the door. That's your first impression, so make sure you make a good one.
Awesome. And as in the STEM office, we do have Patty, who will help you through interviewing, applying to internships, the whole process. So we definitely have that resource for you too. Does anyone else have anything else to add before we go to the next question?
Yeah, I would like to add to Joel's comment or answer. He has a good point interviewing, and I would also suggest resume too. Make sure your resume is pretty much on point and really up to date and as efficiently as you can write it. And in interviewing, a lot of times you'll interview and you'll say, oh, why didn't I do that? Why didn't I do this? Or you just won't feel too good about it, but you have to take it as a learning experience. And, you go on to the next interview and, whatever you kind of felt you did wrong there, try to, make adjustments, and then, you'll do better next time. And other people have told me that they've called back and they already told them, hey, you know what, we're actually not fit for us right now. We're gonna go to somebody else. But what would be good is maybe even ask, just say, okay, I understand, but what did I do, I guess, wrong, or what can I do to improve my interview skills? And maybe they'll give you some pointers, and you take that for the next time. You move forward with that. So I would suggest that.
Yeah, to go a little bit on top of that, of your comment there, resumes are really important. Formatting is a huge thing. If I can't read your resume, and this is a lot of other hiring managers that I work with, if it's not formatted in a way that shows that you're an organized person, we won't even read it. So make sure you're organized in what you have in your resume. That's really important. And following up is really good. It shows that you're not. It does not show that you're desperate. It shows that you're really interested in the job. So that follow up is really good. And yeah, don't get discouraged by people not calling you back or there'll be more interviews. Just keep on following it up.
Just to add to the interview part, I've realized that a lot of our own recruiters use LinkedIn a lot. Like most of our candidates that we find are actually through LinkedIn, and then we ask for the more document, like the longer resume to look at the keywords and stuff. So if you don't have LinkedIn right now, you should get an account and put as many like keywords. Like right now, I'm looking more towards software usage, like KUKA robots, FANUC robots, Allen Bradley PLCs. So a lot of keywords actually help. So LinkedIn is pretty good. And a lot of people have actually reached out to recruiters directly and kind of got us to there. But I would say like, don't take it personally if you don't get called back. It may be you don't have the right keywords or we're not looking for a junior at that point in time, but try again.
Yeah, LinkedIn is really good. Another thing, as part of our screening process, we do look through social media. So I know you guys are in college and gonna have fun. Don't post anything that you're gonna regret. We do look through all of that. Even if you're not searchable, we'll find a way to find it. So YouTube, Instagram, Twitter, Facebook, all of that. There have been many candidates that I've found videos that I wouldn't want them to be a part of my team as a result. So they're great candidates technically, but it shows your character when you post things that are inappropriate. So don't forget.
I think we had a couple questions.
You basically answered my question, which was advice on interviewing agencies.
Yeah, Joel, we might have you come back to do interviews for our students.
I'm sorry?
We might have you do mock interviews in the future.
Sure, no problem. As long as it can be through Google Hangout, because I actually live in LA, but I commute to Orange County. So if it's through Google Hangout, I'd love to hang out with you guys. Other than that, it'll take me like 3 hours to get there.
And that's why we do Google Hangout. Nobody wants to. Yep.
I'm just a little curious. You're all very accomplished engineers. Was there ever a time during your schooling when you were, say, to the point where you thought you weren't going to be an engineer, but because of your resolve, you still became one?
Yes, every finals. Every time you curl yourself up in a ball in the library and don't know how you're going to pass the next test, you definitely think you're going to not be an engineer. But I think what's important is just keep on going. You have a goal. You've set a goal for yourself. And I'm a firm believer, if I set a goal for myself, I'm going to achieve that goal. And I think all of you guys, even coming to this class, like listening to us talk, like I'm sure it's not something you have to do, but you guys did it. That shows your will to do that, and you guys want something for yourselves. So just keep on pushing. I think that's what's really most important, and have a really good network of people to help there and support you. It's going to be hard. It's a tough road. Not all engineers finish in 4 years. Some take 6, some take 8. I've seen all of those. I had a friend from college, was a freshman. He was a third-year junior and I still graduated before him. We're still friends now, but he's very successful. He's working for Boeing. It doesn't matter how long you take, as long as you get there and you achieve it.
I wouldn't say that. Sorry, I'm cutting you off, Michael. I wouldn't say that I doubted being an engineer, but the struggle was actually. I kind of enjoyed the struggle because once you were done, you feel really accomplished. Like you're going to struggle, no doubt about it. But once you actually solve the problem, like you get that eureka moment or the air matches that high that you got, like I fixed it, I solved it. No one else thought that they could fix it, but I did it. And so you have to like bear the pain to feel the reward of it. So just realize that it'll have a happy ending once you solve it. I think the thing that I doubt now is actually management, because I like lead a team at the moment, and that's a totally different skill set. That's like solving a problem on a robot. The robot will do the same thing over and over again, but people are always different, and each person is different every day. So I think that's often people talk about that as the career progression. But I know a lot of people who kind of stay on the technical side because they like it a little bit more, and that's totally fine in itself.
Yeah, going the manager.
Oh, yeah. Once you start working, there's totally different avenues. Yeah, go ahead, Joel.
As I said, going the manager route is not necessarily what you learn in school either. Even getting a master's, that's not really what it's for. I would say that 50% of my day is managing people's personalities. So it can be a very fun thing to do. But it's very challenging, but it's very rewarding at the same time, because you're not only helping guide a project, you're helping people grow as part of it.
Michael, did you want to add something?
Yeah, I think really understanding what it is that motivates you, really, whether it's personal achievement, whether, pursuing another degree, whether making that career advancement, salary, whatever it is that motivates you, use that to give you the edge on a personal level. In school was easy for me. I would see friends that would fail math 3 times in a row, but they kept at it. But seeing that motivated me even more, because yes, although it came easy to me, I was still able to help others out by either tutoring or with setting up group study sessions. Again, using that network and finding that extra motivation, because you're your own best cheerleader. At the end of the day, nobody else is going to want it as bad as you are going to want it. Yeah, as far as I can say.
Yeah, I'd like to add, there's always going to be self-doubt. There's always going to be kind of like, am I really going to finish? Can I really do this? And it's just, at times you get so frustrated, whether you're doing homework or projects. Sometimes just take a step back, kind of clear your head, and then get back at it. And understand that you do go through struggles. It's not going to be easy, but obviously you won't really understand what achievement is if you don't struggle. So, yeah, there was times, I'm sure everybody could vouch for me that, there's times you're like, wow, like, can I really do this? It's just so much, so a lot of times you just have so much power on top, classes, work, but you just have to keep going. I used to work in the shipping department. One of our couriers that we used to send out told me, he's like, kind of pretty much gave me advice, like 10 years is going to pass by. Whether you finish school or don't, those 10 years are still going to pass by. So might as well just keep at it, keep going. And in 10 years, you're already going to be done with working. So that really kind of might as well just keep going. Just take it day by day. Sometimes that's all you have to do. Sometimes that's all you can do. Take it day by day, do what you got to do. And little by little, time's going to pass by regardless. And you'll realize, it's a good feeling to kind of see that, wow, I did this. Now, you kind of just keep progressing, keep moving forward. So, yeah.
We'll probably do 2 more questions and then we'll wrap it up so they can enjoy their Friday.
I was just wondering if they can comment. It's kind of specific to one case, but like people who would come to engineering later, already had another career and going to engineering later, like what the temperature of that is in the industry and even at school.
Yeah. So the question was about, because we are a community college where we have a lot of students who are coming from a different field. They're switching careers and now want to get into engineering because it's their love. What is the temperature like in your companies where you see people who might, have changed their careers recently, received their degrees, and getting a job out there in the field?
At work, I
or-
haven't. At work, I haven't really come across that, but I do have a friend. She went to UCLA, majored in business. Then she started working within her field, and then she went back to school at CSUN to pursue mechanical engineering. For her, it's been working out. I believe. Oh well, yeah, she's with Northrop now. But beyond that, at work, I haven't seen it directly with the team I work with, but I know it's possible. I think what did it for her was her network. Who did she know who could help her out to one, go back to school for a second bachelor's, and then once she was ready to obtain that internship, then I think it really can only help you out because now you bring two separate expertises from they're related fields in their own way. Everything comes down to budget, really. So how can you use that in the team that you're working with?
Yeah, I met somebody at work. He's not on my team. He's on a different department, but he actually came from political science bachelor's. He worked in marketing, and then he went back to school to get a master's in, I believe it was computer engineering. So it's doable. I mean, I was surprised. I was like, political science to engineering. And she said, yeah, it wasn't for me. So it is definitely doable. Going back to what Michael said, I think the big thing is your network. When you're in school, trying to talk to as many people, you make a lot of friends, networking, and ultimately, once you're done with school or you're looking for internships, that network, that's where it kind of comes into play. And as Michael said, now you bring two different types of expertise. You know what I mean? Not just the engineering side, because obviously you're going to school for it or you finish school for it, but whatever other degree you do have already. So it's doable. You know what I mean? And as long as I was just strongly network. I kind of learned that a little bit the hard way, but networking is pretty much number one. And I like going to school because that can really help you out and kind of open up different avenues for you. So yeah.
It's definitely possible to change careers. My two brothers actually did that. Like my oldest brother did immunology and like a bio major, and then now he's working as a systems engineer in as a computer science person. But he's always liked computers, so we always told him like, why did you do bio in the beginning anyway? So the computers were the natural fit. And my other brother was actually he initially did chemistry and then did economics, graduated with an economics degree and worked for a bank for a couple of years. And then the economy went downhill. Then he realized like he didn't like the banking industry so much. So he actually went to become a doctor. So now he's a doctor in the Kaiser in Hawaii. So it all worked out. Took a lot though. Took a lot of loans, took a lot of time, took a lot of tests. But it all worked out at the end.
Yeah, I have a couple of people that I've hired. One was an art major. Did nothing with it for like 2 or 3 years and then went back for mechanical engineering. He's kind of a diamond in the rough for what I was looking for at the time. We were looking for somebody that can do silicone molding, and a lot of the silicone molding was done as part of his art classes. So he was actually able to start designing parts while using his art degree and use his mechanical engineering degree. So he calls work playtime because he gets to use his art degree, which he thought he would never get to use. So it's definitely possible.
Cool. And then one more question.
Yeah. I just want to kind of ask the economical side. I know I'm in a community college, so the cost is very minimal, but once I transfer to the big schools, it's going to get a lot greater. I just kind of want to know the key arrangements that they probably did or had help from either internships, paid internships, or scholarships, where could have they gotten that extra money to pay their tuition?
So the question was about money-wise, right? Community college right now, we pay $46 per unit. So that transition to the university is definitely a big shock for a lot of our students. How did you supplement whether it was loans, financial aid, or maybe you received a stipend from your internships, or maybe you had a job yourself? what did you do to help support yourself through college?
I actually had a full-time job while I was working, or while I was going to school. Unfortunately, it wasn't in engineering, but I actually worked for Starbucks for all throughout college and kind of helped myself get through college. With that, if you are going to work yourself through college, I would recommend trying to find an internship, especially within a field that you're interested in. That way, you can either get a job there, or you can find out that you don't want to work in that particular sector. If you can find a year-round internship, that would be my recommendation.
Yeah, internships help. I'm actually looking for interns also because I require that the internships last at least 6 months, because you really can't learn enough in like a 3-month summer internship. So I actually don't like that Berkeley is very resistant to having co-ops. A lot of schools in the U.S. force you to leave, to like leave the school formally and then reapply, which one of my interns who had to like technically leave MIT to do the internship, it was fine to come back. It does, but as long as you talk to the career center and make sure that they know what you're doing, I think it should be fine to go back to school. And some schools actually require internships. I think like Michigan State actually does that. I'm not sure so much like Northwestern or Northeastern requires co-ops. So if you were to look at bigger schools, they require you to actually go work at a job to actually graduate. So I think if you're going in a technical field, that's actually a really good way to go. For me personally, I got scholarships. So I had applied to a lot of different scholarships. The UCs have something called the Regent Scholarship. If you're within a certain percentile of your class in high school, or I think there are usually a lot of other scholarships as well, but you just have to find ones. And I actually applied for a lot of the smaller ones, because the big ones, a lot of people apply for, but there were like a couple of ones that were like a couple hundred here and there. And you can keep applying while you're in school as well. People stop applying after they get into college, but there's still a lot within it. And a couple of friends did receive it like in their second year or third year.
So for me, it was a mixture between student loans, financial aid, working part-time on campus, and little side jobs that I could pick up here and there. But if I could go back, I would definitely pursue internship. Just know that obviously with the loans, there's subsidized and unsubsidized. You want the one that doesn't rack up the interest until after you graduate, or else, I mean, yeah, it's ridiculous amounts with the interest rate. But yeah, first and foremost, if you can, pursue the internship. CSUN, they do co-ops, but they do have limitations as to the number of students they can pick up, and use your network.
Yeah, for me, it was, I worked full-time for about a little bit less than half. Then I was working part-time to pretty much I paid through all my schooling. I worked through all my schooling, and I paid my tuition. I got financial aid on and off here and there. I did get a scholarship for about a year. So I would suggest, just scholarships. Try to, I didn't want to get any loans out. That's why I just forced myself to work through school. Well, yeah, definitely I would suggest the scholarships. And obviously, if you can get an internship, that would help you out. I would say paid internship would help. And then not only that, but as Joel said, that you can kind of see what you like and don't like. And so, yeah, definitely.
Financial aid is definitely really helpful. A lot of you might already qualify for financial aid, and some of that does carry over when you transfer out. The UC specifically has the Blue and Gold Opportunity Plan, which actually kind of acts like the BOG fee waiver. So how many of you received the BOG fee waiver right now, where you only pay your health fees? and your materials and stuff. So the Blue and Gold Opportunity Plan actually serves kind of like that, where they take care of your tuition for families who earn $80,000 or less. So the only thing you have to pay for is your living expenses if you're going to be moving out, and then like books and all of the supplies that you need. So that's definitely a big help that a lot of students don't take advantage of, or they automatically think that UC has a bigger price tag, I'm going to just apply to the Cal States. So definitely consider that. Cal States also have their own university grants that they offer, in addition to other financial aid opportunities from the government. So I think that concludes our session. We just do have one more question for you all. And I guess it's any last advice. We're so grateful that you joined us and shared your experiences with our students. What last advice do you want to give to our community college students who are looking to get into the field of engineering and before they go on and transfer?
I think it's actually really good that you guys are attending this right now. I would give that advice of attending similar things to this, or maybe some type of clubs or networking events. That way you can kind of talk to engineers that are in the field or in school to become engineers and kind of like understand what it takes, what they're doing from day to day, or what they did to get where they are, and have an idea. You know, if you're going to civil, let's see if you can talk to a civil engineer and see, okay, what do you do? You know, and also maybe talk to different types of engineering fields to get an idea or a better idea. Because for me, I didn't really know what engineering was when I was going to school, and I was trying to decide, okay, you know, should I become mechanical, electrical? So I would suggest that, and it's really good that you guys are attending this right now and getting kind of a feel for what's out there, or what path you guys want to do. So it's really good that you guys are kind of like thinking about it, and it's, you know, the wheels are spinning. You know what I mean? And you want to kind of learn and see what path you guys should take. So that's my big advice. And networking, definitely. So yeah.
Some of my advice would be ask a lot of questions, as many questions. If you don't know it, just ask it. You're going to learn something out of it. Stay humble. I've seen a lot of new engineers and new graduates come in and think they know it all. You don't know it. You don't know anything. Always come with a mindset that you don't know it and you want to learn it. So I think that would be my big piece of advice. So don't be a millennial, essentially. Yeah, internships, big thing. Everybody get one. If you want to come out to Orange County, I have plenty of openings in the summer, so I can share that with Angela.
Jennifer?
Advice as you're transitioning. I think this is an experience that you'll carry with you, and hopefully will give you that humility and that strong work ethic that we look for when we're looking to hire more people. Like it's not always the people who talk the best or like I'm looking for, like, when I'm hiring more people, I'm looking for like a spirit of people who want to just do it and try it, like that are relentless and want to keep growing. I think as you go back to school or you're in this community college phase, it shows that you are willing to do something to make yourself better. And I tried to, like, nothing will be handed to you. You have to go find it, and that's something that we need in every workplace. If you're willing to put yourself out there and try new things and try to make yourself improve, that's something that and will just permeate through how you represent yourself in interviews and resumes. Like, don't be afraid to show that you have struggled and that you survived the struggle.
And Michael?
So I would say be prepared for rejection. The first jobs, the first internships that you apply to, you may not necessarily get them, but then what do you do when that does happen? Do you have a backup plan? Does it have to do with you maybe moving to another state for the summer to take that internship? If you do think about those kind of risks, make sure that they're calculated. I did have the opportunity to go to Washington to intern for the Center of Disease Control, but I turned that down because I had a more certain job on campus through the summer, and I just didn't want to deal with the move. But really along the way, you'll find that all these opportunities will come up. Make sure that they're the right opportunity for you, for what you're trying to learn, what you're trying to accomplish. Are they in line with your goals and values? Make sure that you stay true to those values and don't give up on your own process of learning. Stay committed to it and focus above all. That really makes all the difference. Once you transfer, you'll find that on-campus involvement is such a big thing, and it's easy to go from studying that extra 4 or 5 hours for that test to maybe going out with a group of friends to that social or that party. Really consider all these factors and be committed to what you're trying to pursue in that transferring from community college to that 4 or 5 year university.
Thanks. Michael, do you want to do a plug for SHIP?
Excuse me?
Do you want to do a plug for SHIP?
A plug?
Yeah, talk about SHIP.
Oh, sure. Yeah. So I'm part of the Society of Hispanic Professional Engineers. I'm actually the External Affairs Vice President right now, serving as the interim president. So what SHIP is, it's a community-based society helping out K through 12 and university students trying to pursue STEM fields. So that's science, technology, engineering, and mathematics. What we do is try to connect students with professionals, students with professional development, interpersonal skills, really trying to enrich the process that you have through your undergraduate career. We do have a meeting coming up in October, which will take place in Pacoima City Hall. I'll share the details with Angela, but really like getting involved in these sort of societies, I know they enriched my experience. At CSUN, I served as president in my senior year, and it was taking a zero-based membership to a membership of about 70 students and really letting that take over and then creating to what it is today, but really enriching your experience as much as you can.
Yeah, I would like to quickly add on top of that. I joined SHIP pretty much a little bit after that I finished school, and man, I wish I had done that back when I was in school. So I would like to definitely emphasize that, that's something you guys should look into, because it's really cool. You meet a lot of cool people, a lot of great people, a lot of people that can help you along the way and give you advice. And so definitely look into that for SHIP.
We do have a SHIP on campus, so if you want to learn more about that, definitely contact me. We also work with SHIP to have events on campus, so definitely look out for that if you want to get involved. Well, thanks so much for spending your Friday with us. I think we learned a great insight, including myself, about what it is that you do day to day, and I'm pretty sure they all learned a lot of great things too. So we just really want to thank you for spending your time with us. And then if you want to be a mentor or maybe allow our students to contact you, just email me, let me know if that's okay, and I can share the contacts if they want to, if they have specific questions for you. You can just let me know, it's fine.